Hello guys, in this video we're going to be looking at some more equations with logarithms, and we'll get straight right into it. So this will be the first example that we'll look at. That's going to be log to the base 6 of x equals 1 minus log to the base 6 of x plus 1. So again, the first thing that we're going to do is on one side of the equals, we're going to get everything with a log there, and on the other side, we'll have everything without a log. So with this one, I'm just going to add log to the base 6 of x plus 1 to both sides. So I should get log to the base 6 of x plus log to the base 6 of x plus 1, and that equals 1. Okay, and then from this stage, I'm going to use my log laws to combine these two things. So I get log to the base 6 of, I multiply x with x plus 1, so I'm just going to write that with a bracket like this, x multiplied by x plus 1, and that equals 1. Okay, at this stage, what I'm going to do now is this. I'm going to say that I've got my base 6, and to get from 6 to x plus 1, I have to raise 6 to the power of 1. So 6 to the power of 1 equals x multiplied by x plus 1. Okay, I'll tidy that up. On the left hand side I have just 6. On the right hand side I expand. I get x squared plus x. I notice that I have a quadratic, so I'm going to make it equal to 0. So I'm going to say x squared plus x minus 6 is equal to 0. Question, can I factorize this? Can I factorize this? Yes, I can. Two numbers that multiply to give minus 6 and add to give positive 1. Well, that's going to be positive 3 and negative 2, so that factorizes to x plus 3, x minus 2, and that equals 0. That gives me that x equals minus 3 or x equals 2. Now with this question, again, we just have to check and be very, very careful. So I'm just going to write the original equation, which was log to the base 6 of x equals 1 minus log to the base 6 of x plus 1. Now if I just check that, log to the base 6 of x, if I were to put x equals minus 3, that would not work because you cannot put a negative number as an argument for your log. So actually the only solution is x is equal to 2. Right. Let's look at another example. Okay, and this is our next example. Log to the base 2 of 2x plus 1 plus equals 3 plus 2 log to the base 2 of x. Again, same thing. I'm going to get everything with a log on one side and everything without a log on the other. So I'm just going to subtract 2 log to the base 2 of x from both sides. So I get log to the base 2 of 2x plus 1 equals, not equals because I'm subtracting, take away 2 log to the base 2 of x, and that equals 3. Okay, now I'm going to combine these using my log laws. So again, remember, I have to rewrite the second part using the power law so that they both have the same coefficient. So I have log to the base 2 of 2x plus 1 take away log to the base 2 of x squared, which equals 3. Okay, now I can combine this using the division law. So I get log to the base 2 of 2x plus 1 all over x squared is equal to 3. To get from the base 2 to 2x plus 1 over x squared, I have to raise it to the power of 3. So I write that as 2 to the power of 3, which equals 2x plus 1 over x squared. From here, I can simplify, so I can say that 2 to the power of 3 is 8. So 8 equals 2x plus 1 over x squared. Multiplying both sides by x squared, I get 8x squared equals 2x plus 1. Again, this is a quadratic, so I'm going to make everything equal to 0. So I get 8x squared minus 2x minus 1, which equals 0. Okay, and we need to solve this. We can actually factorize this one. So if you take 8 and multiply it by minus 1, that gives you minus 8. So I'm just going to write that here. Two numbers that multiply to give minus 8 and add to give minus 2. That's going to be minus 4 and positive 2. So I have 8x squared minus 4x plus 2x minus 1 equals 0. And then, factorizing the left-hand side, I get 4x, 2x minus 1, plus 1, lots of 2x minus 1, which equals 0. Take out a common factor of 2x minus 1, I get 2x minus 1, multiplied by what's left, which is 4x plus 1, which equals 0. So that gives me either x equals a half or x equals minus a quarter. Now again, I remind you that we have to be very careful. So let me just rewrite the question. Okay, so that's the question rewritten. And again, just note that I'm going to take the bit on the right, sorry. So if I take the 2 log to the base 2 of x, and I put in x equals minus a quarter, that doesn't work because logs cannot take negative numbers. So actually, I only have the solution x equals a half. Right, we'll look at one last type of question, which is it tends to be split into two separate parts. So here it is. Okay, so this is the first part of the question. Given that log to the base 3 of x plus 1 is equal to 1 plus 2 log to the base 3 of x minus 1, show that 3x squared minus 7x plus 2 equals 0. So again, we approach it no differently to how we've done before. What we're going to do is get everything with logs on one side and everything without logs on the other. So I'm going to subtract 2 log to the base 3 of x minus 1 from both sides, giving me this. Log to the base 3 of x plus 1 minus 2 log to the base 3 of x minus 1 is equal to 1. And again, combining the logs, I need to use my log laws. So I have log to the base 3 of x plus 1 minus, using the power law, I get log to the base 3 of x minus 1 squared, which equals 1. Now I can combine the two things. So I have, combining the two logs using the division law, log to the base 3 of x plus 1 over x minus 1 squared. giving 1. Now again, to get from base 3 to x plus 1 over x minus 1 squared, I have to raise 3 to the power of 1. So I get 3 to the power of 1 is equal to x plus 1 over x minus 1 all squared. Like that. Okay, and then I'm just going to rewrite this. So we have the 3 to the power of 1, of course, is 3. So that's 3 is equal to x plus 1 over x minus 1 squared. Then that gives me 3 multiplied by x minus 1 squared is equal to x plus 1. And then I expand x minus 1. We should know the expansion of x minus 1. That's going to be x squared minus 2x plus 1, which equals x plus 1. Expanding the left-hand side, I get 3x squared minus 6x plus 3, which equals x plus 1. And then what I'm going to do is just make everything equal to 0. So I get 3x squared minus 7x plus 2, which equals 0. And that's what we were asked to show. Right, so the next part is saying, hence or otherwise, solve log to the base 3 of x plus 1 equals 1 plus 2 log to the base 3 of x minus 1. So if you notice, this is actually the same question. So the first part asked us to show this result here. So what we're going to do now is use that to then solve the equation. So our first line, we can start off by just saying 3x squared minus 7x plus 2 is equal to 0. Again, it's a quadratic. It's already equal to 0 because that's what we had to do in the first part. So let's solve it. I believe we can factorize this one. 3 multiplied by 2 gives you 6. Two numbers that multiply to give you positive 6, but add to give minus 7. That's going to be minus 6 and minus 1. So I get 3x squared minus 6x minus x plus 2, which equals 0. And then factorizing each bit, I get 3x multiplied by x minus 2. And then I take away 1. And I have x minus 2 again. The minus 1 and the minus 2 multiply to give you the plus 2, which gives you 0. Take out a factor of x minus 2. And then I'm left with 3x minus 1, which equals 0. Okay, and then from here I can see that my solutions are x equals 2 or x equals a third. And yet again, I must always be careful by checking with the question whether both these solutions are allowed. So I'm just going to rewrite the equation. Okay, great. So it does look like both of these values of x, 2 and a third, can be used. However, so if you look at the first bit, we have log to the base 3 of x plus 1. Both 2 and a third can go in there. But if you look at the second part, 2 log to the base 3 of x minus 1, if you put a third in there, I get 2 log to the base 3 of, instead of writing x, I'm going to put a third, minus 1, which gives me 2 log to the base 3 of, well, third minus 1 is going to be minus 2/3. So again, that doesn't work. It does not work. However, it does work for x equals 2. Because when you put 2 in, you get 2 minus 1, which is just 1, and that is allowed. Remember, logs cannot take negative numbers. So our only solution is actually going to be, let me just go back so that you can see. It's actually only going to be x is equal to 2. Okay, so again, when you're solving equations with logs, be very, very careful that if you have a quadratic or any other type of equation, that your answers are allowed, or make sure you only select the answers which are allowed. Alright, that's it for now. I'll catch you in another video.